All right, good morning, everyone.
Good morning.
Wait, can you say that one more time, Keandra?
I was saying good morning.
Okay, no. When you said it the first time, it didn't come through the audio here. So I wanted to make sure that was all working.
Okay, so you're good now.
Yep, good now. Thank you. All right, so I know I had one person who said they were going to be late for a good reason. And hopefully everyone in EBC isn't waiting for Brooks to show up. He's not going to be here today. So I'm going to give them time to just get in before I give the daily quiz. The daily quiz will probably happen closer to the end of class today. So I'm just going to go ahead and start on the lecture. And, if they miss an out, it's just being recorded so they can go watch the recording afterwards. Okay, so we're not going to start with daily quiz. We will do that later. There's still going to be a daily quiz for today. All right, so screen. There we go. Just got in, was it? Yeah. All right. So just because I saw one more person come in, I'm not going to start with the daily quiz. We will be doing it, but we're not going to start with the daily quiz today. So we're talking about different ways to combine sets, talk about set operations essentially. And first one is, or the first two that we talked about, intersection and union. Intersection is finding the intersection of the two sets, what they share in common. So we have that nice little Venn diagram. Oh no, let's try something. So you're gonna let me write? So no, okay. So I won't do that.
Morning, Professor.
Good morning. What's up?
You can hear me?
Yes, ma'am.
Oh, okay. I'm in what is 305?
Are you the only one there?
No, we have what's your name? Ray's here too.
Oh,
The
right.
internet,
Okay.
yeah, but the internet is not working on this campus at this moment.
Oh.
The box Wi-Fi. Oh wait, no. It just connected.
Okay, I was about to say sometimes it takes a little bit to connect. But so
you had a quiz this morning?
No, so not yet.
Okay.
We're going to have a quiz.
Okay.
I knew some people would be coming in late, so I was going to push it off to a little bit later. So we're just hopping straight into the lecture right now.
Okay, thank you.
Yeah. All right. So intersection, union. Intersection is finding out what they have in common. Unions are just bringing everything that they have together, right? The key thing with unions is just don't make sure you have repeated values. So that's what we saw as example number 4 right here, right? Those two sets that we defined, A and B, both share 2 and 4. I only need to account for them once because anytime I write a set, it needs to be in unordered. So it doesn't matter what order I write them in, though usually we would probably prefer ascending order. It's just how we naturally see the numbers. But it doesn't matter what the order is, but they have to be unique elements, right? That was the key, unique elements. And then the last thing that we defined was cardinality. And cardinality was a relatively simple concept in that it's just the number of elements in the set. So sets can have different elements, different objects, but cardinality just cares about, well, how many there are. So we went through and we found it, and then I had a couple minutes that I couldn't really get into another topic. So I just took you all into this cool little idea that you have different types of infinite, actually. And it's actually a pretty expansive area to study in mathematics. You can have sets that are infinite. You can have sets that are infinite times infinite cardinality, and you can have sets that are infinite to the infinite cardinality, and then have infinite exponents of infinite. So something like infinity to the infinity to the infinity to the infinity, and it just keeps going. There are sets out there that have that type of cardinality. So even though we think of infinite as this set concept of a never increasing number, we can actually classify different types of infinite. Anyway, that was for the fun fact, and let's just start getting back into sets, because there's still more operations and things that we can do. The next one is actually comparing, ways to compare sets. So first one is what's going to be called a subset. Whoops. So we got a definition, and we're going to start with the same premise that we're going to be doing a lot throughout today and probably on Monday. Let A and B be sets, right? We just need to talk about two sets. That's the premise we're going to give ourselves. We say A is a subset of B. And it's going to be denoted as this. So I have A, and the better way to think of it is like elongated C with a, whoops, I don't want the line underneath it, but an elongated C. And essentially what you're thinking of here is a rounded out less than symbol. It's a great way to describe it. It's a rounded out less than symbol, because just like how we use less than or greater than to compare numbers, we're going to kind of hijack that symbol a little bit, modify it a little bit as well to compare sets. So denoted A subset B if every element of A is an element of B. Okay. A is a subset of B if every element of A is an element of B. Just an alternative way to write this definition. A is a subset of B given that X being an element of A implies X is an element of B. Okay. So essentially, anytime we want to prove, oh, let me talk a second. Anytime we want to prove subsets, something is a subset of the other, I got to show everything that's in that lesser set is in the larger set. If it fails, that means there is one thing that is in this set A that is not in this set B. Okay, so let's get some practice messing around with this definition. So we're going to define 4 sets for us. Okay, first one. Whoops. Is it freeze or is this pen just not wanting to work? One second. Technology's not want to work with me. If you want to go ahead and write it down though, A is going to be the set of numbers 1 through 10. Use that ellipsis. So I was just going to write 1, 2, 3, ... 10. The numbers 1 through 10. All right, I don't know why. There we go, 2, 3. So A is going to be the set of numbers 1 through 10. B is going to be the set of even numbers between 0 and 10. So 2, 4, 6, 8, and 10. We're going to define C to be 1, 2, 3, and 4. And last but not least, we're going to take D to be 7, 8, 9, and 10. So those are our sets, and we're going to just determine if the following statements are true or false. And of course, I always have to justify. I always have to justify. So first up, I'll write a couple out actually. Oops, that subset symbol's worse than usual. All right. So very first one, B is a subset of A. Is that true or false?
Oh, that's true.
What was that? Sorry.
I was saying it's true.
Yeah, it's true. Because I look at that lesser set that I'm saying here, right? That's set on the left of the symbol of B. And I say, okay, is every element in B an element of A? Well, the answer is yes. It's true because 2, 4, 6, 8, and 10 are an element of B. And 2, 4, 6, 8, 10 are elements of A. Does A have other things in its set? Absolutely. But when we're trying to compare the sets B and A with this subset operator, all I care about is, are the things that are in B also in this set A? What about that second one? Is A a subset of C? Yes or no?
I would say false.
Right. You didn't sound too confident with that answer though, so I'm going to ask if anyone else has an opinion as well.
It might be false too.
Yeah, it might be false.
All right, I'm getting a lot of people going with them on false. All right, Keandre, though, you gave us the first response. Give us justify. Why do you think this is false?
I would say false because the elements of A that are in elements of C, but I will more so go with that saying that there are more elements of A that are not in C as well. So they do have some elements, but they don't fully, like C doesn't have as many elements as A.
Yeah, so here's the key. You're picking up on it. Every element of A. So I guess technically I should be putting that for all symbol there, right? Every element of that first set needs to be an element of the second set. And you're absolutely right, right? Between A and C, they do share some elements. They share specifically 1, 2, 3, 4, and 5. However, the set A has many more things other than it. Specifically, I can pick one of those numbers, let's say 5. Well, 5, whoops, I didn't think I was writing blue. Go back to black. 5 is an element of A. But 5 is not an element of C. And for it to be a subset, every element of A would have to be an element of C. So there's my counterexample. This is why it's a false statement. Okay. Questions so far? Good. All right, let's work on D. Oh, go ahead. Oh, no questions.
I was saying no questions. It was like the explanation you gave was clear enough, so I know exactly.
Perfect, thank you. All right, what about D is a subset of B? All right, Deanna came out and said false pretty quickly.
I would say false as well.
Yeah. All right. So Deanna, you're the first one to respond this time. So justify it, right? That's one thing we always have to do.
So I will just got 7 and 9 are elements of D, but they're not elements of B.
Yeah.
That's why I said no.
Yeah. So 7 is an element of D. But 7 is not an element of B.
What was 7 and 9?
Yeah. Technically, 9, it's a good thing to note. But to fail that definition, I only just need 1. Mhm. Only need 1 to fail the definition because, again, I'm going to scroll up. Every element. That's the key. If I don't have every element, it's done. So if you wanted to justify it by also saying instead 9 is an element of D, but 9 is not an element of B, still correct justification. One of those things, it's easier to prove something is false, provide a counterexample, only have to provide one thing. To show something is true with sets, especially this subset or what we're going to get to next, or set equality, it's a lot harder because I have to show everything, right?
Yeah.
I have to go through every possible case. All right, so I'm trying not to. Get too lazy. All right, so 3 more. 3 more here. C is a subset of A. True or false?
True.
True. I look at all of my elements in C, which is 1, 2, 3, and 4. And I look at A and I say, hey, each one of those is also an element of A.
No.
So this is true because 1, 2, 3, and 4, which are my elements of C, are an A, and that is every element of C. What about this next one? Let me rewrite that symbol. That's what I meant to write, though. I'm just trying to get rid of that rounding at the top. This 5th statement, is this true? Or false?
I'll go with true.
True. All right. We got 1 true. Anyone else?
True.
All right. Ray said true.
True.
Hakeem says true. We got this truth train going. Someone read off that statement to me, though.
It doesn't have all elements of A though.
The statement says B is an element of A.
B is an element of A. Am I talking about subsets here?
No.
No, that's the trick. I'm trying to make sure you're being careful when reading this notation. I know my handwriting can be sloppy sometimes, so it doesn't make it nicer, but we still have to be diligent. I see this symbol. This should be something that is pretty knowledgeable to me. I'm using it in all my other statements, right? Is an element. So what I have to ask myself here is the set containing 2, 4, 6, 8, and 10, is that set an element of A?
Yes, it is.
So the set A contains other sets?
No, you're saying it like that. It doesn't contain other sets, but it does contain other elements.
It does contain some of those elements, but I'm not asking is, the set A containing the elements of B. I'd be writing the subset symbol, right? Here I'm doing that element. I'm asking is the set containing 2, 4, 6, 8, and 10, is that an object in the set A? And it is not, right? Objects are separated by those commas, and I don't see anywhere in there this set. I can scroll away because I see some faces. I purposefully did this one. We can go back to an example that we gave near the beginning, these tricky examples. The second one, set B, right? So this is one of the examples I said, be careful when you're reading this notation. The set B right here contains the element X, the element Y. Its third element is the set containing 1, 2, and 3, and its fourth element was triangle. Okay. So this set B here does contain another set inside of it, the set containing 1, 2, and 3. However, this set B does not contain 1, it does not contain 2, it does not contain 3. Okay. So just that nice little lesson, we got to be careful when reading this notation. Sorry, going back down so you can finish writing all that stuff. All right. What about that last one? Number 6. Is the set containing 4 a subset of B? True or false?
I think it would be true.
Okay. All right, Akeem, justify it.
Because how I'm thinking about the 4, unless 4 is an object and 4 is an element, then there's the element 4 in B. So that's why I'm thinking it's true.
Perfect reasoning. You're absolutely correct. So we were given originally the set containing the element 4, right? And we're asked, is the set containing the element 4 a subset of B? Well, I still ask myself the same question, is everything in this first set an element of the second set? Well, there's only one thing in there. It's the element 4. And we know that 4 is in this set B. So everything in that first set, which is just the set containing 4, is an element of the set B. So they are, or this is a true statement. The set containing 4 is a subset of B. So how are we feeling? Good. Questions if you got them.
Can we go back over number 5? Okay.
So does the set A contain any other sets?
No, those
No.
are just elements within it, right?
Yes. So elements are the stuff inside of sets. And what are the elements of A?
Now, the elements of A are 1 through 10.
1 through 10, right? The number 1, the number 2, the number 3, the number 4, blah, 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 to the number 10. And what I'm asking in that fifth statement is the set containing 2, 4, 6, 8, and 10. Not 2, 4, 6, 8, and 10 on their own. Is the set containing 2, 4, 6, 8, and 10 one of those objects, one of those elements that you listed off to?
Oh, so like the E symbol is talking about sets, whereas the sideways U is talking about the elements within the sets, effectively.
Subsets versus elements, yeah.
Yeah, all right, I get it.
The E, it's an epsilon. That is membership. That is an element of. That's one of those things that we defined like last week, right? This new one, this sideways, I think of it more as an elongated C than the sideways U, but sideways U also works perfectly, actually, now that I think about it. That always is just talking about subsets, talking about, okay, does the elements in this set also contained in this set not? So really that fifth one's about reading the notation correctly. All All right. Next up, another definition. Again, same premise, let A and B be sets. We say that A and B are equal and just denoted as A equals B if every element of A is an element of B and vice versa. And every element of B is an element of A. I guess I'll just write out, I won't use vice versa. So essentially, how we can think of this is A is equal to B if A is a subset of B and B is a subset of A. Because we're saying with those two subset statements, everything that's in A is contained in B, and then also on the flip side, everything that's in B is contained in A. And for those two things to be true, then, well, we have to automatically assume that they're the exact same elements, the exact same number of elements as well. So they have to be the same sets. So talking about set equality is really just showing subsets, right? So I'm going to have it pose a question for y'all. Let A be the set of all integers x such that x is a multiple of 3 and define this set B to be the set of all integers such that they are a multiple of 9. So I'm defining A to be the set of all integers that are a multiple of 3. We're defining B to be the set of all integers that are a multiple of 9. So then the question I have for you is B, is this set B a subset of the set A? Yes or no?
I'm thinking that yes, B would be a subset of A in this scenario.
So even if I'm just trying to get, and you're correct, it would be, but for the rest of y'all, because I know I felt the silence and I saw the looks from a lot of people, you were contemplating whether or not this is true. Think about this set, right? There's no reason I can't, to try to get a better handle maybe on what are the elements in this set, just start writing some of them out. Right? Multiples of 3, would be 3, 6, 9, 12, 15, 18, 21, 24, and so on, right? But since this is also integers, I can go into the negatives. So -3, -6, -9, and so on. So I just start listing those out in my head, and I go, okay, well, in this set B, what's in there? Well, what are my multiples of 9? Well, 9, 18, 27, and then I could go into the negative direction, right? -9, -18, -27. And do I see, just by after listing out those elements, those things that are in B, are those going to be also in A? Are they going to be in set A? Are the elements of B, like something like 9, is 9 in A? Yeah. Is 18 going to be in the set A? Yeah. 27. -18.
Yeah.
Absolutely. So that's my clue, or my clue that I can give myself that this is a true statement. But just like anything that we do in this course, we have to justify it. And this is where we're going to have to write a simple proof. But it's just a justification, a way that I can say if I am in set B, so if I'm a multiple of 9, I'm going to show you that I also have to be a multiple of 3. So I do this again with the proofs that we've been writing before in this class. Start with my assumption that I'm in B. Okay. And I'm not going to tell you exactly what that element is. I'm going to keep it general, right? Because then I'm going to say, if you give me a specific value, this same logic is going to apply to anything that you pull out in particular. So I'm just going to choose a general element. So I'm going to choose a variable x. X is in this set B. If it's in B, I don't have to make any big jumps logically. By the definition of that set B, this implies that x is what? If I'm in this set B, that means I am what?
Multiple of 9.
Is a multiple of 9. So that means whatever this number is that I picked out is a multiple of 9. Well, if it's a multiple of 9, how can I write this? Well, it's just going to be equal to 9 times something. Right? If it's a multiple of 9, this means it's either 9 times 1, 9 times 2, 9 times 1,000, 9 times -243. I don't know. I really don't care. I know it's going to be 9 times something. That's what it means to be a multiple of 9. So just recapping the statements that we have, if we take an element of B, that directly implies that it's a multiple of 9. And being a multiple of 9 directly implies that I can write this thing as 9 times some other number. Remember, my goal is to show that this thing is an A, that x is an element of A. So I want to see if I can use this to rewrite it as 3 times something. Well, I can't, because 9 itself is what times what? 3 times 3.
3 times 3.
Yeah. So being able to write this as x is equal to 9 times some number means I can rewrite this as 3 times m which implies that this is just going to be the same thing as 3 times some integer. But what can I now say about x? It is a multiple of what? since I can write this as 3 times some integer, I can then say that x is a multiple of what?
A multiple of 3.
Yeah, is a multiple of 3. And then I get my last implication. If x is a multiple of 3, then what set does it belong to?
Plus A.
Belongs in that set A. Trying to keep it all on the same page. So we have chosen an element of B, and we have taken small logical or made small logical deductions based on all these definitions that we have, right? To be in B means it's a multiple of 9. For it to be a multiple of 9, that means I need to be able to write it as 9 times something. Well, if I can write it as 9 times something, I can break up that 9 into a 3 times 3 and just group that extra 3 that I have with that something from before. And that's just going to give me 3 times some integer. Well, if I can write this number x, whatever it is 3 times some integer, then that means it's a multiple of 3. And if it's a multiple of 3, then it's in this set A. So I've taken a general element of B, I've never told you exactly what it was, and showed that it has to also be in A, which implies that every element of B is an element of A. And if that's the case, what do we say about B and A? Well, B is a subset of A. That's why we come to this conclusion that it's a yes. So, questions? If you have them, if not, give me a thumbs up. Cool. All right. Second thing I got for you. Oops, I don't need to write this that big. Are these two sets equal? I don't think I can keep the definitions in. So just remembering A is the set of all multiples of 3 and B is the set of all multiples 9. Are these two sets the same thing? What do y'all think? Yes or no?
I don't think so.
All right, I got one no in here.
I also say no.
All right, got 2 no's. Okay, and y'all are correct. This is false. Okay, but again, I have to justify it, right? That's one of the things, and we have to justify it through a proof. Small logical deductions that will lead me to why this is not the case, right? But if I'm trying to prove something isn't true, all I need to do is provide a counterexample. Well, let's just recap then, what do I need to provide a counterexample to? So for it to be equal, remember, this implies that A is a subset of B and B is a subset of A. That's what it means for these two sets to be equal. And we just went through a nice little proof to show that all multiples of 9 are also multiples of 3. That is, B is a subset of A. So if I want to make this statement A equals B or B equals A false, that means this other case that I'd have to hold for these to be equal must be false. Okay, A is not a subset of B. So to show that these two things aren't equal, I just need to prove that A is not a subset of B, that there is something that is a multiple of 3 that is also not a multiple of 9. So to show A is not equal to B, need to justify that A is not a subset of B. And again, I just want to denote the opposite or the not, I just draw a line through it. And all I have to do is pick a counterexample. What is an element in A that is not going to be an element of B? So what is a multiple of 3 that is not a multiple of 9? 6. So 6 would be an element of A. It is a multiple of 3, specifically 3 times 2. However, 6 is not an element, whoops, I about said of 9, of B. Thus, I directly get that I will not be able to satisfy that definition of being a subset, because it's got to be every element of A has to be in B for it to be a subset. So they're not. A is not a subset of B. Well, and because A is not a subset of B, then these two sets can't be equal. We won't satisfy that definition. Okay. Questions? Looking at the time. Any quick questions? Good.
No questions from me.
Cool. Thank you for telling me. All right. I'm going to take that silence as a key to move on because I want to talk about or introduce 2 other concepts real quick before I give you all that daily quiz. Okay. So 2 more definitions. Okay, first one, again, same premise. Let A and B be sets. We're going to define the set difference. Of A and B. Denoted A, you can think divided by B / B. That's probably what I'm going to say a lot. As all elements in A. That are not in B. Using that set builder notation, all this A remove B or A / B is just going to be all elements in A such that that element is not in B. Okay, so essentially removing anything that's in that intersection, anything that they have in common. That should be a direct /. I don't know why it rounded off. There we go. All right, second one. We're going to define the complement of A. Denoted A with a line over it. So A over line. To be the set of all elements not in A. using that set builder notation. How we're going to define this? Well, remember we have that universal set, that U, indicating all potential elements. So it's going to be containing all the elements in this universal set U, such that it's nothing that was already contained in A. So it's the opposite of what is in A. That's what it means to be the complement. Pictorially, what we're talking about, let's see if I can get it down here. So I'm just going to draw 2 boxes to denote my universe. So everything that I have. And then in this universe, I'm going to have, let's say, 2 sets. A set A and a set B. Right? And there's this potential for overlap. So I just draw a Venn diagram with that potential of, hey, there might be something in between. If I'm talking about A remove B, that's everything that is in that set A. So everything that's in that left circle that is not in B. So I'm just going to zoom in to make this picture a little bit easier to see. Well, it means I just color in. I'm talking about everything that's in A that's not in B. So anything that would be in that intersection, I don't include. So you're seeing me, even though I kind of drew it small to begin with, I'm purposefully leaving out that intersection. Right? Differences are just coming out with everything that is uniquely in A, that is not in this second set. A remove B. That last one, complement. Oops. Oh no. Whoops, I'll just color it back in. So a complement is just talking about everything that isn't in A. So if I set up this same image, have a set A and have a set B and leave room for the potential of some overlap. A complement is everything that is not in A. Well, that will include everything that's in B that wasn't in A. Because if I'm in this little shaded red area, right, I'm not in that circle that's denoting the set A, but that's not the only thing. I've got other stuff outside of that in this universe that isn't in this set A. I've got everything else that can be included from my universe goes into this complement. Because I define the complement by everything that is not in this set A. So that's what it means to be the complement. Everything that is not in A. Okay. All right. So quickly get the daily quiz up. So go ahead and pull up poll everywhere. I'm gonna freeze this so I can exit full screen. Your daily quiz is going to be up in 1 second. So because of the time, I know what time it is. What I'm going to ask you to do is just submit your answer. I'll leave it up for a few minutes after class for you to finish your answer. And then you'll know how you did based on the grade I give you in Blackboard. But what I'll also do is I'll send out an email or a Blackboard announcement with the solution. Okay. So I know I don't have time to cover it in class because of my time limit. Whoops, wrong section. Whoops, that's for 153. I want 233. All right, now the correct daily quiz is up. If you want to see it in Zoom, it's this right here. If A is the set containing 1, 2, and 3, and B is the set containing A, B, and C, determine this thing. I don't want to say it because I want to make sure you're reading this notation correctly. Okay. So once you think you got it, submit your answer, and then you're free to head on out of here. Okay. Once you have submitted your answer, if you have questions for me, feel free to stick around and ask. But first, get that daily quiz done. Okay. Stop share. Make sure you're reading that notation carefully. Just based on 2 of the answers that I've gotten in. I just want to reiterate, like I said before, if you got your answer in, you feel confident with it, you want to go ahead and head on out of here, feel free to leave. Okay. I'm going to be giving the answer in Blackboard. I'll be sending out that announcement. All right. And also make sure that you're leaving on time, and always give a time limit on these daily quizzes. It's already been 2 minutes. I'm going to give y'all just roughly 30 more seconds to get your answers in before I lock it. All right, 15 seconds for those of you who are here still and listening. If that's what you think your answer is, Shanoa or Shanoa, yes, that's what you would type. That's what you think your answer is. All right, I'm gonna lock answers here in 5, 4, 3, 2, 1. Locking answers now. All right, for those of y'all that are here, since I locked it, it's 0. Answer 0. Most of y'all, and most answers were saying empty set or none, which is fine. But that is the intersection, but remembering those absolute value symbols means we're asking for the cardinality of this set. So the answer would actually be 0. So I'll send that out in the announcement though. Y'all have a good rest of your day. Have a good weekend too.
Yeah, thank you.
You guys have a good weekend. Bye-bye.
Bye.